Right, in all of our induction problems that we've seen so far and that we've done so far in the class, the base case has been pretty simple. Hasn't been much to it. It's been like showing that 1 is equal to 1 squared or something like that, or 1 times 2 over 2 is equal to 1 squared or something, you know. Things that you're probably thinking to yourself, why am I even having to do this? Well, you know, the base case is very important. Absolutely necessary. If you don't prove the base case, you can use inductive steps to prove all kinds of things that aren't true. So if you don't have a base case first, it's not true. So you've got to have the base case in an inductive, in a proof by induction. All right, here we have a base case that is not entirely simple. There's actually something to do. All right, so what let me write out P of 0 first. P of 0 is f of 0 times x is equal to 0 times f of x. All right, so that's what we're trying to prove. We want to prove that f of 0 times x is equal to 0 times f of x. All right, so now a little scratch work first. All right, you knew I was going to say it. All right, so f of 0x equals 0 times f of x. Right, that's what we're trying to show. So can we simplify this a little bit? Let's see, f of 0x, well yeah, 0 times x is 0, so this is 0. And what's 0 times f of x? That's 0. So we're really trying to show this. If we show this, then we can build it back up to that, which is what we really want to prove. Okay, and there's a little hint. And this hint is also in the worksheet. It's very similar for that problem. So first we're going to prove f of 0 equals 0 by computing f of 1, or f of 1, right. Okay, so f of 1, right, is equal to f of 0 plus 1, right, because 0 plus 1 is equal to 1. Now, using the property, this special property, we can write this as f of 0 plus f of 1. So f of 1 equals f of 0 plus f of 1. Now, there's two ways to go about proving that f of 0 equals 0 from this. One way is you could do some algebra and subtract f of 1 from both sides, and then you get that f of 0 equals 0. But also, you could take note of the fact that all of this is happening in the natural numbers, right? This is a function, f is a function from the natural numbers to the natural numbers. So the domain is the natural numbers, and the range is the natural numbers. The range is a subset of the natural numbers. It may not be the natural numbers, but it's at least a subset of the natural numbers. F of x values are values in the range, right? So all of this is happening in the natural numbers. And what do we know about the natural numbers? That there's really only one natural number, namely 0, that you can add to something and get the same thing back, right? And so notice that what we have here, right, is that here we've added f of 1, whatever number that is, whatever natural number f of 1 is, we added it to this number f of 0, and we got f of 1 back, right? There's only one number that you can add to f of 1 and get f of 1 back. That's 0. So this property right here, or this line that we have right here, this is the defining property for 0. So f of 0 equals 0. Okay, now let's do this with, so we got that. We established that f of 0 equals 0. Now, left-hand side is f of 0 times x, which equals f of 0, which equals 0, which we just proved, right? Which is equal to 0 times f of x, which is the right-hand side.